Okay, so this video is going to be on section 8.3, and it's going to be on finding an inverse matrix. And this is important because being able to find an inverse matrix allows you to solve a system of equations. So I have this 2 by 2 matrix that I'm wanting to find the inverse of. First of all, you need to understand what the notation is. So a to the negative 1 is the symbolic notation for the inverse of the matrix A. Okay? Now, how do I find the inverse? Well, the inverse matrix, we know that if I take A times A to the negative 1, or A times the inverse matrix, I end up with the identity matrix, which you guys have been using. It's just the matrix that has all ones in the diagonal and zeros everywhere else. So I need to figure out what this is. So I'm going to do that by writing this A as an augmented matrix. Okay. 1, negative 1, 4, negative 3. I really didn't need to make it that big. And then I've got my dashed line. And instead of writing my solutions to the equations there, I'm going to write the identity matrix, which for a 2 by 2 is 1, 0, 0, 1. And then the idea behind finding the inverse is I'm going to switch this identity matrix from this side to this side, literally flip-flop, okay, the 1, 0, 0, 1, so that this matrix on the left-hand side is 1, 0, 0, 1, okay? And then whatever's left on the right-hand side is my A to the negative 1. So we use row operations just like you've previously done. So if you notice, this, I want it to be 1 and then 0, and then 0 and 1. This already has a 1 there. So now I want to get 0 below it. So I think maybe I should take row 1 plus row 2. And that should become my new row 2. Now, why am I doing that? Well, I immediately noticed 1 plus negative 1 would give me the 0 that I want in this first entry. So, try to draw my matrix a little bit smaller. That's pretty big. Now, my first row is not changing, so I'm going to go ahead and fill that in. Okay? Be careful with your algebra here. Most of you that have been making mistakes, it's been because of a silly multiplication or addition error. So 1 plus negative 1 is 0. 4 plus negative 3 is 1. 1 plus 0 is 1. Okay. And then 0 plus 1 is 1. Now again, we're not concerned about what happens here. We need to get this to be 1, 0, 0, 1. And it looks like I'm only missing one thing, and that is that this 4 needs to be a 0. So I have a 1 below it, so if I do negative 4 row 2 and add that to row 1, that's going to become my new row 1. I don't want to change anything about this row. It's already in the correct form. This row is close. This one's not going to change because I'm going to take 0 and add that to it, and then I'm going to change that 4 to the number that I want. So, draw my new matrix. I'm going to draw my dashed line. Okay, right now, my row 2 is not going to change, so I'm going to fill that in. 0, 1, 1, 1. Okay, and then we're going to take 0 times negative 4 and add that to 1. So that's going to stay a 1. Then we're going to take 1 times negative 4 and add that to 4. So we're going to get 0. Then we're going to take 1 times negative 4. So we are going to get negative 3. And then we are going to take 1 times negative 4 and add that to 0. So we're going to get negative 4. And if you notice, I now have my inverse matrix here. My identity matrix, 1, 0, 0, 1, and this side is my inverse matrix. So A to the negative 1 is equal to negative 3, negative 4, 1, 1. And I would be done. Okay? So you're going to go through something very similar for all of this process, okay? It is possible to not have an inverse matrix. Now, how do I figure out the system of equations that would go with this matrix? Okay, that's what I want to know. How do I figure out the system of equations? How do I solve a system of equations using an inverse matrix? Okay, I'm going to go to the back of my paper. Maybe zoom out a little bit. Okay, so we're going to say use the inverse matrix to solve the system. And I can't spell. Solve has an O. Okay, so this is very similar to what you've been doing. So we're going to use an inverse matrix to solve the system. And we are going to do here's our system. Now, the difference here when I'm setting this up, when I set up my matrix, I am not going to include my answers this time. So here's my matrix that represents this system. 2, 3, 1, 3, 3, 1, 2, 4, 1, and then I'm going to go ahead and attach my identity matrix because I need to find the inverse matrix if I want to do this. So that would be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so we're going to start with our row operations. And I want to always start by getting a 1 here. So the first thing I'm going to do is 1/2 row 1. And that's going to become my new row 1. One, 3/2, 1/2, 1/2, 0, 0. And then nothing else changed. Okay, once you've achieved that goal, your next goal should be to get a 0 here and a 0 here. Not even paying attention to what's happening in your other two columns. So I'm going to get a 0 here and a 0 here. So the first thing I'm going to do is I have a 3. So I know I'm going to do -3 row 1 plus row 2. That's going to become my new row 2. So this time I'm going to do this a little bit differently. I'm going to fill in my rows that are not changing. Okay. So I'm taking -3 times 1 and adding it to 3, which will get me the 0 I want. Then I'm taking -3 times 3/2, and I am adding 3 to that, which will be -3/2 here. Okay. Then I'm doing 1/2 times -3 and adding 1 to that, so that will be a -1/2. Then I'm doing 1/2 times -3 and adding that to 0. So I think that will be -3/2. Then I'm multiplying by 0, so I'll have 0 adding 1, 1. And then 0 times -3 plus 0 should still be 0. Okay, now I'm going to get a 0 here. Then I can go back and work on my next column. So I'm going to do -2, row 1, plus row 3, and make that my new row 3. So I'm going to go down here. I'm going to recopy my 2 rows that aren't changing. So, -2, row 1. So I've got -2 times 1 plus 2 should be 0. Then I am doing -2 times 3/2, which should get me -3, and I'm adding that to 4. So that is going to be a 1. Then I'm doing -2 times 1/2, which is going to get me -1, then I'm adding that to 1, so that should get me 0. Okay, then I'm doing -1/2 times -2, that's -1, I'm adding that to 0, so that's going to be a -1. -2 times 0 is 0, and I'm adding that to 0, so this one should be 0. Here I'm doing -2 times 0. I'm adding that to 1, so this would be 1. Now, to me, something exciting just happened. And what exciting just happened is the fact that this, okay, is 0, 1, 0, which is what I want right here. So I think I'm going to switch row 2 and row 3. So 1, 3/2, 1/2, 1/2, 0, 0. And this is going to become 0, 1, 0, -1, 0, 1. And then we're going to have 0, -3/2, -1/2, -3/2, 1, 0. Now I have this row, which is exactly what I want, which means that I want to get zeros everywhere else. So, how am I going to get zeros above it? Some of you might be tempted to say, well, let's add row 1 to row 3 and then make that my new row 3. But if you do that, then your entry in row 3 is going to become a 1, and we do not want that to happen. So what happens if I do row 3 plus row 1 and make that my new row 1? I'm sorry, I'm worried I made a mistake. So I'm going to stop what I'm doing and I will start again when I've made sure that we're right, because I'm seeing that if I did this right now, I'm going to be adding, if I add this row to this row, then this is going to become 0, which is
Wayne
good.
Baker, if you're in the building, please come to the principal's office. Wayne Baker, if you're in the building, please come to the principal's office.
But then I'm going to get a 0 here, so that's not going to help me find the inverse matrix. Okay, I'm going to pause, see part 2 of this video in a moment.